I think the recording is started now.
Okay, thank you.
Alright.
So we will start with the caching concepts and later see how caching will be implemented in an integration server. Uh, so basically, what is caching, right? And what are its capabilities? So to define caching, right, it is basically an optimizing feature which can improve the performance of services. So these are basically all the flow services that we define and invoke on an integration server. And once they are invoked, the performance of that services, how they behave, uh, what happens to the memory management and the CPU utilization, uh, right? And how frequently the data or the services actually contact the disk or the memory of the integration server to pick up the data. This actually defines the need of caching, right? So caching can significantly improve the response time of services that retrieve information from different high traffic web servers and databases. That's what we discussed right now. And it is basically observed and seen that accessing data from memory is like 1,000 times faster than retrieving it from a database. So uh, basically, when we have the flow services which get the request, they will process that particular data and they will contact the database to get the required details and then uh, give the particular response back to the client, right? But the main thing in any production environment or uh, for that matter, for any live environment, is that the service performance should be optimum. So when we say it should be optimum, that is, it should be available all the time. And secondly, when a request hits that particular service, the time from when the request hits and the data is captured and given back to the client. So the response time should always be minimal, right? And this is one of the the KRA of any uh, environment on production, and web methods is not an exception to that. So that's the reason we are talking about the caching concept today. And further integration server and components that run on integration server like the trading networks. So they use Terracotta EH cache to cache data which is associated with many of their internal operations. So we will see about the EH cache and its feature, what it means. But um, basically, we will just discuss about some of the further roles of data caching. Like the integration server, it provides different, services which are inbuilt or they are out of the box when the product is installed, and the developers can simply use them to add to the caching capabilities of the solutions that they develop. Uh, so let me just open the integration server. Right. Now, when a service that frequently reads data from, like, say, for example, a particular key and value pair, which is, residing on a cache or a part of that to avoid hitting the database each time, it needs access to that particular cache. So, cache is basically a form of or a temporary existence of data which is held in the memory of a JVM instance of an integration server. So it is as basic as that. We can define what is caching, right? So as a result, the developer can use the service results of caching. So what it means is when a particular service is invoked, it will execute and it will produce the particular output. That output or the results may be required in future for future invocations, right? So these results are stored in the form of a cache for a specified period. So there is a time period for which this particular cache exists, and then it will expire. So for the future invocations, the cache enabled service will not hit the database. Rather, it will produce the output directly from the cache, which already has the results from the past invocations, right? So that's about the service results. Then data caching. So in data caching, the developer can obviously define individual caches in which service can cache data, and services that want to get the data from this particular data caching, they can make use of the caching services. So we have the out of the box different services like the pub.cache folder in WM Public. It can be used to basically maintain this data caching. So what it means is that, say for example, we can imagine of a key and value pair, right? Like a config files that in our traditional integrations, the developer used to maintain them on disk. And then based upon the key, the value used to be generated and it used to be passed on to the clients, or the service used to make use of that particular value for that key, and it used to produce the output by processing it. So um, we will see about these services once I show you on the integration server. So Terracotta Cache also enables this kind of cache to be, stored virtually for any kind of objects. Okay, so there are two, properties of a service, or we can say there are two types of services based upon the service caching. So we have a stateful service and we have a stateless service. So what is a stateless service? Basically, say for example, there is a web service which is hosted on an integration server, and we have a client which invokes this web service. So it runs or it executes on the integration server, and then the particular response is generated, and it is returned back to the client. So if that particular service is a stateless service, then once the response is returned back to the client, that is the full life cycle of the service invocation ends over there, and the session with that service by the client gets terminated by integration server, because there is no need for any session or any state to be maintained by the integration server, as it is a stateless service. Now, how do we basically define a stateless service? So let me just open Designer. Okay, so I'm just creating a package by the name supplier management. And in this, I will create a new folder. So So I have the same folder as the package. And in this, I'll be creating a new flow service. So this will basically fetch the supplier details. Uh, I mean, it hope to hit the database and then uh, get the details for me. So this is a flow service. It is, you know, an empty flow service, but its main objective is it will get the request from the client and it will basically use any of the JDBC adapters to fetch the records from the database. Now, basically, you see that in the runtime property, right, of the service, there is a property called as stateless. And by default, it is true. So what it means is that whatever services that we create, they are not, meant for caching. Uh, the simple reason being that its value is true over here. And you see that when it is a stateless service, the cache results will be false. And these values will not be used. So to make it a stateful service, we have to, uh, you know, change this Boolean value to false for stateless and cache results will be true. So once I save this, uh, this will be a stateful service, right? And if I want to reset the cache, it will be reset over here. So right. So now, as you can see that this service get supply details. We have an entry for get supply details in the cache and prefetch information, right? So as of now, we don't have any hits for this service, but but what we can observe is that we have one new service that we already defined in the designer, that is get supply details, and it is a cached service. So its entry will um, be in the the cache and prefetch information. So any questions on this so far? Okay, so I take it as a no. Now, cache expire is always.
Yeah, sorry, Assalamu alaikum. Sorry, Dashrat. I was talking and the mic was off.
Yeah,
For the
that's fine.
for the caching itself, is it cached in which component of the is it in the web methods integration server or API gateway? Let's assume we have an HTTP request that the developer had enabled the caching.
Okay, so I think I can answer that question, but I will get to that topic later. So we are yet to go up till there, right? So once I discuss the architecture of caching, we'll come to know. But till here, whatever we discussed, do we have any doubts so far?
Seems no.
Okay, fine. So as I was mentioning, the cache expire time is 15 seconds, right? So this is basically a very basic, caching concept from a service perspective. Or you might say that any developer would like to know the prerequisites and the basic knowledge of caching right from the service development. Uh, So that's what this slide talks about, right? Like it talks about the stateless and the stateful services, right? So let's understand why do we need stateless and why do we need stateful services. So as I mentioned, stateless services are basically they are just request and response and then forget. That is, the session is automatically terminated by the integration server. So when we actually require a stateless service, so this is basically when we have to, retrieve data from a static data source. So that is when we need stateless services. And I mean, when the particular invocations happen with the same set of inputs, that is when you need stateless services, right? Then when do we need the caching to be enabled for services, right? So say for example, we we understand the architecture of a particular flow service, right? So a flow service basically has any kind of a config value, and say the invocation or the request contains one of the keys, and the config values is a straightforward value that has to be picked up. So it is basically something that is like a result that has to be used over and over again for each invocation. So when a particular service require the state information from earlier transactions, so that is what it says, that when you hit the service with the same set of inputs, then obviously there won't be any change of data that is to be passed on to the client, right? But when we talk about, say, uh, supplier details, right? Uh, so what do you understand? There will be some kind of details in a database, and then you will have the code, and this particular code will hit the database and it will fetch that particular supplier, which is specific to that code. So in this case, the output will vary each time depending upon the input, right? So you cannot cache these type of services, right? So that's what it talks about. That is when it requires real-time data and or the invocations are with unique inputs. So that is when you need to enable service caching. Okay, so I would like to ask the gentleman to repeat his question, because I think we have come to this slide again, and I would be able to answer that question right now.
Can you go back to the previous slide, please?
Okay.
Can you turn off the caching even if the developer has enabled the caching?
Yes, an admin can do that.
Admin of what? Admin which component?
Right. So we actually have the caching which we define in the admin UI, right? And as an administrator, we can shut down the cache manager. So I think I need to discuss that as well. I will show you how we can turn off the cache managers in the admin UI.
No, I'm
Can be
talking
done.
about a certain API, that a certain API or a certain subdomain or a certain web service that we have enabled. The developer has enabled the caching in the, let's say, headers of the HTTP request. Is it possible to remove caching by the API gateway or by the web component or web methods? to remove the header there. Is that possible?
Yes, we can do that. So if you see here, we have this particular information. Say, for example, if you consider this as a web service, right?
Okay.
This is a get supplier details, and it has these many methods which are allowed. So the operations that you can do are you can either test that service, or you can reset the service cache, or you can list the service cache. But you are not getting an option to turn down the service cache for this particular service.
So is it possible or not here?
No, you can't do that. So I'm talking about the integration server.
Yeah, okay. But coming back to my previous question about the what is the I was talking about the what is the physical in which component does the physical RAM is consumed by the cache? Is it in Terracotta or web methods or integration server or where?
Right. So right now we are talking about heap cache, right? So what it means by heap cache is basically the JVM of an integration server. It will be responsible to maintain the cache that we are defining or we are talking about right now. So obviously it will be maintained on the integration server JVM. And then there is a second type, which is the off heap memory, which is basically a big memory component of integration server. Sorry, not integration server, of web method suite. And this big memory, I will come to that architecture, but I think I have answered your question, right? The current.
Yes, thank you.
Yeah.
But here, I have points here. Now you are talking about two type of caches, heap cache and big memory cache. Now, in heap memory, that meaning per instance or per JVM. Each JVM has its own cache, right?
Yes, correct.
Okay, in this case, if the service here, or if I use integration server on multiple JVMs, so what the benefit here if the calls coming to the second JVMs while the cache on the first JVM?
Okay, so there is I think these questions you will come to know later on, but I will shortly answer this. So you are concerned about a cache which has to be synchronized across multiple integration servers, right?
Yes, sir. Why we are depend on heap cache while we have a Terracotta in the environments? Why not all caching through the Terracotta big memory?
Yes,
Why?
we are going to
why-
discuss about the big memory caching as well, the distributed cache. But to start with, we need to understand, right, the different types of caches and its architecture. So right now we are discussing about the heap. So this is a simple standalone cache, right? To understand the concept of caches. So that's what I said, like I'll be going to that particular topic of distributed caching and big memory or off heap memory caching.
Okay, but the control here, cache control, meaning heap caching or Terracotta. The cache control and in the service usage, we see a cache matrix. This is related to heap cache or Terracotta.
This is related to the heap cache.
So
You're talking
yes,
about this
yes,
server cache.
yes.
Okay.
In the bottom, cache and prefetch information. This is heap
Yes.
cache.
Yes, this is heap cache. So I have not yet started Terracotta topic. We are simply discussing about the heap cache. This is a standalone instance of integration server, and the cache that the services we'll be using as of now will be the JVM cache, JVM heap memory.
Okay, so I hope in the coming slides, okay, to see the configurations related to the heap cache, how we can control and how we can configure the heap cache and the behavior of it.
Yes, I'm coming to that topic.
Okay.
Okay, so so that's about the stateless and stateful services that we have discussed. Now let's talk about the different cache managers that we have for web methods. And the out-of-the-box cache manager that we have is the Software AG IS services. So this is an inbuilt cache manager which the suite comes with, and there is a cache called as service results. So it's because, let me just go to that particular. So if you come to this particular settings and caching, you will see there is a system cache managers, and in that there is softwareag.is.services. Now this particular cache manager, it is only talking about the the cache data that is generated from a service on integration server. And then if you go inside, there will be a cache which is defined as service results. So these are the predefined cache managers that come out of the box, and any cache manager which has its name which starts with software AG, that will be considered as a system cache manager. And the ones that we will or the developer will um, you know kind of develop on the integration server, that will be called as a public cache. So here we are talking about two types of cache managers that the web method suite provides us with, right? So let's go ahead and create a cache manager. So clicking on Add Cache Manager will actually generate this screen. It will ask for the name. So the name is supplier info. And right now I'm not giving any URL for the Terracotta server because we are just concerned with the cache manager on heap memory. So if I click Save Changes, it says Added Cache Manager. So you see there is a supplier info, which is a public cache. So it's of type public cache and it is added. So let's go inside this public cache. And over here, we need to add a cache. So let's add a cache with the name as supplier details. And it is mandatory to give the maximum elements in the memory. So I give it as 500. Time to live, it can be 15 seconds. And if it has to be stored on disk or overflow to disk, meaning if the elements get exceeded, then this cache manager will use the disk space of that particular IS. So right now I'm just keeping it very simple. So I'm saving it. Now a cache has been created, and to enable, I will enable this particular cache. Right. So to enable the cache first, the cache manager has to be started. So here you see that there is a reload option which is currently disabled. That's because this cache manager is shut down. So I'll go ahead and I'll start the cache manager. So you can see that the reload option is now in blue. So if we go in the cache manager, we see that the cache has been enabled as well. Right. So how the developers basically use this is we were talking about the inbuilt services in WM Public. So let me just locate WM Public package in that pub, in that cache. So in pub.cache, we have the get cache. And if I just give the cache manager name over here, and the key and the cache, so it will be supplier details. And then we have the put service. So what does a put service do is it will actually write the information to the cache, and the get service will actually you know get the information from the cache. So I've just shown the basic services in WM Public. Then you can have different other uh, services, like it will search for the keys, or it will get the keys, and it will remove. So these are all the basic operations that we can do on a cache manager using the public services, right? So coming,
I have a question here. Now, if a developers create a package over the lower environment, for example, development environments, and he create a custom cache or a system cache. Now, when moving to the production environment, deploying over the production environments, we need also to create this caching manually, or it will be with the deployment package deployment set.
yes, we can either create them manually on the servers, or I mean, that's the only way that we can do it in the production environment, right? As you see that this is not an asset that we get in here. So if I show you, so we have created this cache manager, right?
Yes, yes, yes. I see the steps how to create a cache manager and create a cache inside cache manager. I mean, these steps, it will be manual. For example, if the developer define a package and the services with the custom cache.
Yes, so I'm just answering your question. I got your question there. So I'm just showing you where does a cache manager exists on, on that particular instance. So if you go in the instance, you will have config, and then you will have caching. So you see that this particular cache manager resides on the disk, right?
Okay.
Yeah. So that's the reason why we cannot, you know, simply move it as an asset from the lower environment to the production environment. And physically, we need to create an cache over there. So yeah. So coming back to our topic of caching, right? So we have seen two different types, that is the system cache and we have the public cache that we define. So what does it do, right? So it actually gets you all the details uh, for that particular service, and it will also give the different hits that have happened to that cache. So all this actually happens through the system cache that we already get, that is softwareag.is.services and the service results. So it stores all the service results, and this will basically show us all the output in the service usage. Okay, so let's now talk about the architecture of the caching, right? So we had a couple of questions already wherein we discussed about two types of caching, right? So to gentlemen, your question about the off heap memory. So this slide exactly answers that question, right? So as I just mentioned, that heap memory is nothing but the memory which a JVM allocates, right? So this JVM will be the integration server JVM, and the cache that we defined locally, this is of no use for us because in production environment we generally have a a clustered environment of at least two or more than two integration servers. So if we have a heap cache, then this particular cache will not be synchronized with another IS in the cluster. So that is basically a drawback, or you can say a disadvantage of on heap cache. Now, second disadvantage is that a JVM is always performing, say, for example, garbage collection, right? When there are certain elements which are not used, they will be discarded or purged, and this will be a routine job of a JVM. Now, what happens is during a garbage collection, the memory consumption of that JVM increases. And due to that, there will be obviously a crunch of memory, and it will um, further affect the performance of the on heap cache. So that's the second disadvantage. So the reason behind off heap memory, that is the big memory. So big memory is a component which gets shipped with the web method suite, and we came up with this particular concept just because we had to synchronize the cache that we are defining on our integration server, right? So what is big memory or off heap storage? It is basically an extension to EH cache that enables you to create caches that reside outside the Java JVM heap, right? So this is a very important statement. And gentlemen, I think this statement answers your question, your previous question, right? About the big memory or off heap memory. Now, the main advantage of this big memory is that we can just scale the particular memory to many of hundreds of GBs, and that will uh, boost the performance of any service invocation. So when you configure a cache to use big memory or off storage, it is very important to understand that a part of it actually resides within the heap. This is because there has to be a reference from the JVM heap uh, to the big memory off heap storage. And that is how any service, you know, um, contacts the off heap memory. When a big memory cache resides off heap, as we discussed, that uh, there is no connection with the JVM garbage collection process, because it is like we are segregating the heap memory to a different, or a what do you say, a different portion which is new to the JVM memory. So for large cache, big memory off heap generally delivers better performance than a heaped based caches. Then the big memory off heap are generally also easier to manage, because they are not subjected, or they are not affected by the garbage collection activity that a JVM performs. Okay, and coming to the entries that can be stored in the cache, that is either on heap or off heap, it actually depends upon how many entries will be stored, and the size of the key and the value, and the size of your Java heap, uh, and obviously off heap memory. So the another advantage, which is obviously not listed here, so when we use a big memory or off heap memory, uh, say for example, in the production environment, when we observe that the memory consumption, or the off heap memory consumption, comes close to 90%, we can easily do the maintenance, right? We can scale up the memory, and we can uh, do it without any downtime. But that is not the case with on-heap memory. So it's very important to understand the difference between on-heap and off-heap memory. Okay, so let's talk about how caching is implemented in big memory. Now, this is a purely administrator topic. So if, say for example, if we are using a big memory or off heap memory, from a developer perspective, it is still going to be the same process. He or she is going to define the stateful services, and they are going to also have the caches which are um, to be defined here. The only difference is that um, while defining the public caches, uh, there will be two options. That is the Terracotta server array URLs that we need to supply from a configuration perspective, and the big memory, that is the off heap memory, which is to be allocated. So that can be done here, wherein you can just create an big memory configuration and then save the changes, and you're good to go for using the off heap memory. Okay, so coming back to this diagram, now, as I said, big memory is an component which is different than a Terracotta. So here you see there are two integration servers, and one is on port 5555 and another one is on port 7555, right? So these two are in cluster. They are having a same communication layer. And then you have the Terracotta server array for clustering and caching. But here we are actually using the big memory, that is the off heap memory, which is not part of the Terracotta. So the difference is that we can either kind of club this big memory with the Terracotta server array, and it can be used as part of EHCache, or it can be used as part of on-heap memory. And then we can have the big memory as the off-heap memory for integration server. Okay, so the traditional Java garbage collection does not affect this architecture, and it works everywhere, wherein the EHCache does with the standalone and distributed caches, right? So distributed caches, they require the use of TSA. So in a TSA, you have Terracotta strips, which are actually synchronized, and they form a cluster for load balancing and clustering and caching. And then obviously you have the big memory, and they have a dedicated disk for scaling of the Terracotta server arrays. So here you see the big memory or the off heap storage can exist at level 1, or if you're using a TSA, it can be configured in level 2 as well. So this particular component here, that is the big memory, that is off heap memory, this is optional in some of the architectures, but you need to have the on heap memory in the JVM. Although if you are using a Terracotta server array, it will be having a dedicated off heap big memory. So did you understand this architecture? Because it is very important. And based on this, the designs or the configurations of the systems will be done. So it's very important to understand how a big memory is configured either on a Terracotta server array or on the integration server. In either case, a big memory is every time an off heap memory. It's going to be an off heap memory every time.
On the Terracotta server array, in this diagram, it's a 2 machine, right? Active
Yes.
and standby machine. How the sync? Is there any sync between these 2 machines about memory or about the cache?
Yeah, so as you can see, this is a communication layer, right? So as of now, there will be one active server that will be getting the requests, and it will be using its own big memory. But because we have a TSA which is clustered, although the second layer is on standby, there will be the synchronization of the off heap memory between active and standby nodes. And that's the reason when the active goes down and there is a failover to standby, this standby will become then active. But then without synchronization, um, there will be loss of data and the architecture won't work properly. So that's the reason the active and standby nodes have to be in synchronized mode always.
Okay, the sync over, it will sync persistent data that saved on the disk.
Yes.
Right?
Yes, correct.
Okay. Other question about Terracotta. Terracotta just one active server. I cannot make multiple active servers.
Obviously, we can have multiple active servers. So in that case, this one will be active and this one will be active as well, right?
Okay.
Now the only question is whether you need an active configuration, because the cost of maintenance and usability will increase in this architecture. Obviously, the fault tolerance and the high availability will be there in active, right? It will be more than 99%. But on a standby, when this goes down, this node becomes active. Even this is high availability, but there will be a certain time frame until this becomes active. Although from the caching perspective or the data perspective, there won't be any difference.
Okay. When the server rebooted, for example, the active and standby, is the data still persistent or will be removed from the cache?
No, the data will be persistent because that's what we discussed, right? That the communication channel actually synchronizes the data from active to standby. So when standby becomes active, it has to have all the data from this node.
No. What I mean, if both servers are rebooted, active and standby.
At the same time,
Yes, at the same time, and it become up after that. Is the data that already cached still in the cache, still in the disk, or will be flushed?
see the disk data, that is persistent data. You can obviously have that, right, when the server comes up. But if both of them are rebooted at the same time, then because this is a cached memory, right? This is not a persistent disk memory. So this data will be lost. And that's the reason we never have, parallel reboot of the nodes. The nodes are always rebooted one after the other.
No, just this is questions. For example, if we have any disaster that both node are goes down, we need to know is the data still persistent or will be gone. Now, the data on the disk will be persistent, but there is some data on the memory, still not going to the disk, right? These data on the memory will be flushed.
That's correct. Yes.
Okay, clear. Thank you.
Okay, so now coming to the licensing of the big memory and Terracotta. So in order to use the big memory or off-heap storage for caching, you need to have the appropriate Terracotta license. And if you want to view the Terracotta license, then you need to have the big memory option as yes. So what it means is so let's go to the licensing details over here. Right. So this shows the integration server licensing, right? So we have the integration server product and we have the licensing for that. Now for Terracotta, it says that because we have not supplied the license file, this component is not active. And then we have the big memory, which is currently set as no. So let's go and just add the license so that we can see what actually happens there. So if I just go to so I am in Software AG 1015 integration server instances, the default, and then in config. So over here I have license key.xml, which is currently used. So this is the integration server proprietary license. And then I have actually kept a Terracotta license key here, right? So let me add this license key and then we will see if that activates the component. Okay, so I'm restarting the server. Okay, I have configured the license and the server is getting restarted. So till then, we will just discuss about the licensing aspect. So I have one more instance of integration server, and this is a purely API gateway instance. I don't have so here you see I don't have the adapters or the common directory services. And if I go into the server licensing, here you see I don't have the publish subscribe or the adapter runtime and guaranteed delivery. I only have the microservices and clustering. And over here, I have the API gateway license. So here you see I have the license for policy management, that is threat protection, and the gateway application management API and app mesh, right? So let me just bring up this instance. Take too long. Okay, so till then, if there are any more questions on this architecture, feel free to ask, because this is a very important concept, right? Yeah. Okay, so I will just move ahead and we will see how we can configure the off-heap memory on the integration server. So this is basically a configuration where we are talking about a big memory or the off-heap storage with EHCache on the integration server. So it does not include the TSA as of now. What we need to do is there is a file called as customwrapper.conf. I'll just go to that particular file. So it's in profiles, IS default, configuration, custom wrapper.conf. Okay, right. So over here, we need to add one entry with the key as wrapper.java.additional. Now we already have the key number as 304. So in case if we need to add it, it will be 305 for us. So the value that we have to add will be something like this, 305, and it will have the value as max direct memory size, and this will be 500 MB. So it will allocate an additional 500 MB on top of the JVM heap, but on the integration server memory itself, right? So when we add this key and restart the integration server, provided we have the big memory license, this will be our only setup that is required to start with the big memory off heap storage, right? And in case if you are using a TSA, that is Terracotta Server Array, then the big memory off heap storage, it will be done in the tcconfig.xml of Terracotta, which we can see in the further discussion. So let's check for this IS. Okay. Okay, so the IS is started. So now you see that after adding the license file for Terracotta, we have the big memory enabled on integration server. Now it is up to us. Either we can use the off heap on the IS itself, or we can use the TSA separately, right? So coming back to this diagram, we will be having, so we are talking about 4 different integration servers. So these are two L1 servers and these are two L2 servers. The L2 servers will act only as TSA. And for TSA, we can actually host the big memory separately, right? So that's about caching. Now, coming to the clustering for integration server. So clustering actually provides the load balancing and failover protection. What is load balancing? Load balancing is basically when a particular node is serving requests with high volume or high capacity, its capacity consumption is very high, then the load will be distributed automatically with the help of a different node or a second node in the cluster, and it will be balanced equally. And the subsequent requests that will be coming, they will be served uh, by the second node in the cluster. And secondly, the failover protection. So failover, it's kind of, say, for example, in this diagram, we have two nodes in cluster and we have a load balancer in between, and the requests that come from the clients. So these are outside of the local network. So we have the firewalls and then the load balancer. So say, for example, one node fails, right? The load balancer will automatically serve the requests to the second node, and it will help in having no downtime with regards to the client. The client will not even come to know whether there is a downtime and any of the server nodes has come down. So that is failover protection that we have. So yeah, so it spreads the workload over several servers, and this improves the performance as we discussed. And it avoids a single point of failure. So if a server cannot handle a request or becomes unavailable, the request is directed automatically to another server in the cluster. So that's what it means by load balancing and failover. Now, an IS can typically, uh, contribute to the requests through many forms. Like it can have a generic HTTPS, or it can have a Java API, which can be exposed, or it can have a remote invocation, or an FTP, that is file transfer protocol, or through email and web service. So we can have a web service provider, and the provider will expose the web service URL to the client, and further it will be consumed. So these are all the various ways through which a client directs the traffic to the load balancer. Uh, so in a clustered integration servers, we generally use load balancer for all clients, and there is no additional client coding that is necessary. So all the requests from the client, they have to come to the load balancer first, excuse me, and from the load balancer, they will be redirected to the internal integration servers. Now there are two configurations that we can have for an integration server cluster. It can be a stateless for stateless sessions, or it can have a stateful wherein we have the shared distributed cache in big memory, and it can actually help in storing the session information. So that is when a particular client request has a certain expiry time. Till that time, that particular session will be held in a shared distributed cache in big memory. So we will talk about the distributed cache and its architecture. So here you see, right, this is a stateless architecture. We have the clients and the load balancer. So the client sends the traffic to the load balancer. Then we have two nodes for the backend IS, and these serve as the virtual servers. Now the thing is, these are stateless. So what it means is that each IS has its different DB. They don't have any mechanism for synchronization, right? Because this particular node and this particular node have different DBs. So what it states is that a stateless mechanism can have multiple servers acting as a single system on a shared server. And there is no need for any identical packages or assets to be on this servers. So there is no cluster penalty, and many servers can be added to the hardware load balancer pool. But in very few architectures, you can see this type of configuration. So to basically solve the adversities of this architecture, we have the stateful virtual servers.
But before that, before going to a stateful virtual server, stateless virtual server, what the benefits if I have multiple servers not identical and the load are distributed through the load balancer?
Mm-hmm.
So what the benefits here? If these servers not identical and I put it behind a load balancer.
Okay. So you can imagine that a particular server, that is server A and server B, which are behind a load balancer, and they are not identical, right? So a situation where the particular functionality of server A and server B are different, right? But they can form a part of the same load balancer. So the benefit of this architecture is, say for example, we have the backend servers, right? Or the backend applications. So these can share the backend applications, and they can be efficient by actually serving the request. Say for example, okay, so if we consider an mediator, if you know a mediator, right? Or for that matter, API gateway. Now, sometimes what happens is a request for an API contains a query string, and based upon the value of that query string, the particular request is routed to different systems. So this type of architecture is a stateless architecture wherein you can have one API on this machine and another API on another machine, right?
Okay, but in this case, the routing, for example, to machine A or to machine B, not through a load balancer, should be from the layer that make a validations on the query string.
That's correct.
Now, if the validation on the query string on system A and system B in this case should be identical to have the same validation function on both systems. But in this case, in this architecture, to system A and system B behind a load balancer and it's different, not identical, I didn't see any benefit in this one as integration.
Yes. So if you have worked on a mediator, so a mediator is obviously part of of the gateway layer which sits on top of the green zone. So this mediator is actually receiving the request directly from a load balancer,
Mhm.
and it filters the query string based upon the the input. It routes the request either to server A or server B. But talking about the benefits, uh, see, that's where the requirement comes. So if we don't have a routing, then we can obviously uh, keep both the servers with identical packages and identical services, right?
Yes.
The only requirement is that in case of routing, there has to be customized packages on these two servers. And that's why they have a different database, and there is no synchronization between these two,
Okay,
but
and this.
they are connected to the same load balancer.
Okay, but in this case, okay, in this case, we should have what I think we should have mediator before system A and system B between integration server and load balancer. But direct integration server to a load balancer, till now I didn't see any benefits, because if the request coming to a system A, while the correct package of system B, in this case, the requester will get errors. So
Yes,
in
that's
this
correct.
architecture, yes, in this architecture, I think we should include a mediator before this one to be more benefits. But in this case, but in this architecture, as you present now, I think this is will not be, or there is no benefit from it, even for stateless.
Yes. So this was basically the the stepping stone to have a stateful configuration wherein both the servers were having a mirror image. They had the same kind of assets, same kind of packages, and uh, the synchronization was one of the other factor. So all these factors are not present in this architecture, and that's why we cannot see this architecture anymore in any of the environments. All the projects or all the environments will obviously be having a synchronization mechanism, and they will be having identical assets on both the nodes, whether it is an active active or an active passive configuration. Okay, this was basically considered when, say for example, there was a need to save cost, and in that case, say this particular server has only order management capability and this has supplier management capability, but then you don't want a different load balancer for that. So obviously they kept different kind of assets on these servers, but then they connected it to the load balancer. So the stateless services that the we have already seen the benefits and the different use cases. So let's go to the architecture which is in use for most of the projects. So in this architecture, we see that system A and system B, they are well connected with a shared database, right? So yesterday we configured the common database, right? And the same architecture we can see here. So the JDBC pools are shared among the server A and server B. For example, when we deploy the schedulers, right? So they automatically get synced from server A to server B. That's because they share the the distributed cache, and also they have a shared database at the backend. That is the IaaS internals. So these are the stateful virtual servers, and they are multiple servers acting as a single system for fault tolerance on shared server or separate server. And each server is configured to share a DB schema. Then they have a server configuration and packages, which are generally identical. So they use the TSA as the shared distributed cache, right? And the most efficient, way of hosting stateful services. So say, for example, a stateful service on system A is invoked. So once that particular request goes back to the client, this state is preserved, and this state is then entered into the shared distributed cache, so that, say, for example, there is another invocation or same service, but on node B, that is system B, then it will consult the distributed cache to see if there is a stored session, and it will make use of that. So it is the most efficient way of hosting stateful service. And then we have the schedulers, which automatically get synchronized, and the adapter runtime transaction failover. So what it means by adapter runtime transaction failover. So say, for example, we have the adapter services, right? And we have the polling notifications. So the polling notifications poll the DB. And what happens is, say, for example, if a certain service is invoked on, say, system B, then that particular information has to be synchronized with system A. So that happens via the distributed cache again. And the setup and maintenance is somewhat more, because we have a Terracotta component, the TSA component, which is introduced newly in this case.
For the stateful architecture, now the packages, for example, if I have 10 integration servers, and these 10 integration servers behind a load balancer, and I need to deploy a package. The package is stored as a physical files on the integration server, right?
That's correct.
How this package are synchronized between all servers? What the mechanism or what the modules synchronizing the package between servers?
Okay, so right. So say, for example, for the 10 integration servers which are behind the load balancer, if we want to deploy any asset, they have to be deployed on all the 10 servers, right? So do you agree to this point?
That meaning deploying it manually?
Not manually, but we have to present the server address at the time of deployment.
During the deployment, I log into the integration servers through a browser. Okay. I log into the server in the browser, for example, and uploading the packages, or I connect through a designer. Okay. And I make a change on the package. Now connecting to the designer through the host name. This host name, it's through the load balancer, and connecting to one of the integration server. Now I make a change on one of the packages. Now this change, it will affect on a physical file on that integration server. In this case, how the changes on this physical file will be synchronized to other virtual to other integration servers.
Okay,
To make
so
to make sure the packages are synchronized and identical between all integration servers.
right. So say, for example, as a designer, you are obviously a client to the load balancer, right? So when we say that we are client to the load balancer, although we are connected to the server, it is through the load balancer. So whatever changes that we make internally, whether it's a package or it's a configuration change, these changes are automatically reflected through the distributed cache. And what happens is any change that is made on node A is sent as a notification to the distributed cache along with the changes so that these changes are synced globally across all the nodes on that particular uh, you know uh, mm, integration servers which are in the cluster.
So the shared distributed cache also used to sync the configurations, not the real not just real transactions.
That's correct. Yes.
Okay, thank you.
So, but what we have, if we don't have this Terracotta license from the integration cluster, how the synchronization is done in between the servers?
Okay, so there are some, predefined assets which are already synchronized. Say, for example, we use the external database, right? That is the IS internal. So it keeps track of the schedulers, it keeps track of the document history, but not the folders. The physical folders are on the disk and they will never be synchronized, uh, you know, physically without by just having an external database. So you is that what your question was?
Yes, but it is not answering Anna's questions as the mechanism behind the synchronization of the file base. As you mentioned, if depend on the external database,
Okay.
it will not include the files.
Okay, so if we are not using a Terracotta server array, what are we planning to use in that purpose? Because a Terracotta or a TSA is meant for distributed cache, right? And it is also meant for synchronizing all the resources.
Anas, could you confirm that if we already configure the Terracotta clusters inside the integration server, I think we didn't do this, right?
No, Mohammed, for the current setup, yes, Terracotta is configured and license already added to the integration server. But I need to get a confirmations during the sessions about synchronization through the configurations. If it's okay through the shared distributed for the configurations, it's okay. But the Terracotta already configured in our environment.
Okay, so sir, I will park your question as of now, but with regards to the synchronization, obviously we can synchronize the runtime data, right? So that part you're clear, right? And you would like to know about the physical packages that we deploy on the integration servers, right? So you need a mechanism that can synchronize any change in that particular package. Say, for example, if I add a new flow service to that package, you are expecting that this particular change should be reflected in all the other servers, Am I correct?
Yes, correct.
Okay, but here the question is that why would we make a change on a live environment directly on one particular node? Because that is not recommended practice, right?
No,
Via
not
software AG.
not making the change on a particular node. For example, when I connect through a designer requests from me the URL for the integration server, right?
Mhm.
And this URL of the integration server is going through the load balancer.
Yes.
Okay, and load balancer forward the request to one of the integration server. So now my sessions goes to one of 10 servers.
Mhm.
Okay, now I connected to one packages and I make a change on one package. I need to make sure this change on this package are synchronized with all other integration servers.
Okay, now I got you. So basically, you are connecting via designer only to one node, right?
Yeah,
Only to one node of that particular cluster. Okay. So I will park this question as of now, and I will confirm that how we will synchronize the assets automatically once they are changed on one particular node, right?
the same thing.
So
The same thing. For example, if I go to extend configurations, and this configurations is saved as a physical in server.cnf, right? As a physical file on the server, and
Yeah.
I need to make change for one of the parameter. For example, the thread maximum thread numbers, and this configuration value are saved in server.cnf. How this value or how this file are synchronized between all servers.
Okay, got you, got you. So as of now, I don't see that particular synchronization happening, but I need to confirm that. So I will park that question and I will confirm that offline. So is that okay with you? I got your question, what you're asking.
Yes, okay. For example, if you
It's
can
not
get
just about a physical package as such. Sometimes we make changes regarding any configurations, right?
Yeah.
Yes.
And we avoid doing that repetitive task on other nodes. So I will get back to you on this because that's a very good question, and then we can confirm to you. Yeah.
If you can
Thank you.
confirm by tomorrow session, because tomorrow we will have also a sessions. Okay,
Yeah.
you can confirm about this tomorrow.
Okay. All right.
Thank you.
Okay. So basically, this particular invocation cycle actually talks about the advantage of a shared distributed cache. So when a particular request is sent to a load balancer, that request is forwarded to host 1 from the cluster, and it serves that particular request. So the service gets executed on host 1, and the session after the execution is stored in a distributed cache. So this distributed cache is common for host 1 and host 2, as we can see here. And then there is another request which follows from the client to the load balancer. But in this case, it gets diverted to host 2 from the load balancer. So before execution, it will check the particular session info if it exists in the distributed cache. If it does exist, then it will use that particular dynamic information, and it will execute and return back the response to the client. But in this case, it fetches the required information, it retrieves that, and then it executes the service and sends the request back. So basically, this is how a stateful session is synchronized among host 1 and host 2, right? So when we define a particular session, so if I wish to define a session, there will be a time limit in seconds, which will allow me to keep that particular session live for the clients. Otherwise, it will automatically expire on the integration server. So the shared distributed cache are different than the external database. The distributed cache, it contains the configuration and runtime information, right? So these are like the clustering information or the session state data stored by applications. Then we have the trading networks query results and ART polling notifications. So all these particular activities, they generate runtime data, which is, it can be a result of invocation on one IS, and they are stored on the distributed cache. And on the external database, we have the IS internal functional alias. So this functional alias is a part of the JDBC pool, and for integration server to be a part of the cluster, the database that is configured should be the same for all the integration servers, because they store the job description and the guaranteed delivery of the documents, then the information for scheduled jobs, and the messaging provider, the join information like documents, the state of activation, and the cross-reference data. And the supported RDBMS are Oracle, SQL Server, DB2, and AS400. So what are the requirements for a stateful cluster? So all the integration servers, they must have same packages, services, and event subscriptions. Then the listener ports should be identical. That is the port numbers. It cannot be that one port is on 5,000, another port is on 6,000, because these ports are, registered to the load balancer at the front end. Then the users and the ACLs should be same. The license keys should be similar. Then if there is any broker connection, or in case if a connection is there, it should be similar. Then the client prefix and the backend database should be the same. And more important, the clock time. The clock time, if it is not same, it will affect the schedulers. The schedulers won't be able to execute properly, and it will create a an invocation failure on either of the integration servers. If we are using the stateless cluster, then it's okay to not have the same server configuration, and even the packages, they have to be checked. They have to be identical in a stateless cluster as well. So in a disaster recovery, basically there is a challenge that implementing data redundancy for clustering over two data centers. So this has been one of the most important criteria for any disaster recovery. So what happens is, at the point of failure, the data which is captured on one of the data centers, it is a requirement for the business that this data needs to be at the same state when the environment comes up on the different data center. So, say for example, we have guaranteed data consistency, or implementing redundant data by clustering application and big memory. So these particular synchronizations challenges, they are taken care when we have big memory and distributed applications over the data centers. But if the data is shared in a single TSA, then the data redundancy chances are minimized, and the optimum performance is delivered to the client. Splitting the TSA strip into mirror node in the second data center over 2 data centers put the data consistency at risk due to the potential of a split brain scenario. So basically what it means is that if a particular TSA has different mirror nodes in 2 different data centers, then it will not have a consistent data when the particular passive node or the passive data center becomes active. So it has to be consistent, and all the data centers should be in the same TSA strip. So this is basically a disaster recovery scenario, and what it says is that for a TSA, we have an active and a mirror, but then strip 1, strip 2, and different strips of TSA, they are clustered across different sites in the integration server or the green zone. So when web methods integration server cluster across data centers with strip terracotta sites, can actually provide guaranteed data by failover tuning feature. So this provides us one of the solution for redundant data that when the when there is an active passive mechanism and site 2 is passive and site 1 is active in a particular disaster event, this particular data gets synchronized across the cluster, and the failover tuning happens when the synchronization across the 2 sites happen effectively.
So, so for the disaster recovery, I see here 2 parts. One for the terracotta cluster, and the other one for the integration server cluster, right?
No, for integration server, it happens through the TSA, but this particular synchronization is, it happens over the time. It's not necessary that this data synchronization happens only when there is a failover, right?
So synchronizing integration server database is not necessary for the failover?
No, what I mean is, say for example, we have an active and a passive environment. So during a failover, this will become active, right?
Mm-hmm.
But continuously from the time when both the sites are running on a frequent basis, the data synchronization will keep happening. This is to avoid redundancy, and that is what is called as a failover tuning feature. So this keeps happening over the time, but when the Terracotta switches from active to passive, the control is taken over by this integration server site.
No, see, now for the Terracotta, we have now we have two types of cluster. One for the high availability in same data center to have multiple servers, active, standby, and the second one for the disaster recovery. We have mirror. Now we have active, standby, and mirror. Right? Now, the Terracotta cluster, for example, strip 1. We will have 3 servers, for example, active and standby in the site 1 and mirror server in the site 2.
Okay.
No, this is my questions. So we will have 3 servers for Terracotta strip 1, for example, active, standby, mirror. Is it right or no?
No, there are no 3 servers. There are only 2 servers. One is for active and one is for mirror. So a mirror image has to be on site 2.
But
and
here,
the mirror image.
But here we have confusion between high availability and recovery site. High availability meaning having multiple nodes on the same site. If node 1 goes down, node 2 will become up. This is the high availability. Now about recovery, that meaning if site 1 totally goes down, I have mirror or I have synchronizations from this module in site 2 and I can bring it up from site 2.
See, for high availability, we have 2 types, right? Either you can have all the nodes in active mode, or you can have one node as active, another one as passive. Okay, so during a failover, the active goes down and the passive then becomes active. So in both these cases, these will be a type of HA. And when you have a fault tolerance, so in a fault tolerance, you can have both the servers as active. So what happens during an active cluster is all the time when the request is coming, either it can be to node 1 or node 2. All the nodes will serve the request because they are part of the active cluster. But during a passive and active setup, there will be a switch from active to passive, right? And then the third one that we are talking about is a standby. So a standby can be of either of these 2 types. A standby can be active. I mean, it can basically be either switched off, and during a failover, it will first switch on and then it will start serving the request, or the particular data center will be on, but it will not consume the request. It will be, a passive node all the time.
Also on the Terracotta, on the Terracotta cluster, what the maximum number of servers that I can include in one cluster for the Terracotta on one strip?
You can have multiple nodes, right? In one strip, you can have multiple nodes. See, basically, there is no what do you say, limitation of a strip. So in a strip, you can have multiple integration servers. You can combine that in one strip and you can form a Terracotta cluster.
So in this case, I can have multiple servers in the site 1 in the Terracotta, as for example active, standby, and extending to the site 2 as standby.
Yes, you can do that because site 2 will always be in standby mode.
Yes.
Right. So for site 1, you can either configure as active, or you can have an active passive, and you can add multiple Terracotta server nodes over there. That's absolutely fine.
Now, about split brain, you mentioned in the previous slide, there is maybe a split brain happen in Terracotta cluster. Okay, what the causes or what the reasons that cause this split brain?
Okay, so see, splitting the TSA strip, that is locating the mirror node in the second data center over two data centers. So what it means is there is obviously a risk of consistency, right? Now, let's go to this diagram. So split brain will occur when this data and this data will fail to synchronize at this point. Okay, so what it is saying is split brain is a risk. It may or it may not happen.
It depends
Because
on. Okay, continue.
Because this particular data and this particular data, it works on a synchronization algorithm, right? Now, at the time of disaster, say there is a delay of 10 minutes, right? And the cycle will start in next 5 minutes for synchronization. Then there is a loss of that 10-minute data. So that is a split brain scenario. You cannot have a continuous synchronization happening between these two servers or these two sites, right?
See now the parts or the widget that you move the mouse on it, is it integration server database or Terracotta component?
See, these are the integration server components. Okay.
Integration server database, right?
Database, yes.
Okay, now we have Oracle database and we have online synchronizations through DataGuard. And this is making sure even if we have disconnection between two sites, there's no data loss. It will resume the synchronization over database, Oracle database, for example, or Microsoft Always On. Okay. Now, split brain, what meaning? According to our knowledge, split brain, that meaning each node working alone due to a connection from the servers to a database, not related to a synchronization over database layer. It's a connection from the server to a database. But here about Terracotta split brain, that meaning active node and mirror node, there is issue in synchronization or inside Terracotta. If you return to the diagram.
Okay, so let's talk about the data synchronization. Now, Terracotta will not manage the database, right?
Yes,
it
right.
will be managed by the integration servers.
Right.
Now, what happens when active is switched to a mirror? So from this database to this database, the load gets transferred. So this integration server then becomes the active node, and this integration server will only have access to this database.
Yes.
Right? It won't have access to this database. But what it is telling is in the split brain scenario, when this member of TSA switches from active and this mirror becomes active, this whole flow is at risk because this database is not synchronized. Are you getting me what I'm saying?
No, there's a confusion here. Okay. Now, let me ask us one questions. Now you create a cluster over the integration server, right? You make integration server cluster. Now you use Terracotta for this cluster because we read that there's two type of a cluster. Maybe Ignite cluster or Terracotta. I think this is for the API gateway.
This can be for API gateway or this can be for the integration servers on the green zone. But what
Okay.
I'm saying is the synchronization is not managed by the Terracotta cluster.
Yes, right. Yes, right. Synchronization over database, it's managed by the engine itself, by database engine, Oracle or Microsoft SQL or MySQL.
Yes.
Not managed by Terracotta cluster. Now, if now for database synchronizations, it's always in sync. Okay, but one site is active and second site database and second site is a standby. Okay, now if you are talking about Terracotta cluster, ignore now database, ignore database. Okay, now we are talking about Terracotta cluster. Terracotta cluster managing the integration server cluster. Okay, now if the mirror node in site 2 become active, that meaning it will trigger the integration server in site 2 to become active. Right?
Yes.
Okay, in this case, the split brain coming from Terracotta. Why the mirror node become active while we didn't initiate the failover? It automatically initiate itself to become active. Maybe there is latency limitations. That meaning between active and mirror, the latency should not exceed, for example, 5 milliseconds. If the mirror node seeing there is no response from the active node, it will bring itself as active. So in this case, we will have two active nodes, while this should not be happening, right?
Yes, but
Okay.
a
So
failover.
so the split brain issue, it's inside Terracotta. There is a limitations. Maybe we should know about this limitation that cause a split brain. Nothing related to a database. Nothing related to a database because Terracotta not managing database.
Yes, correct. It's not related wholly to a database, but obviously when, say for example, there are certain components that come from a database to an integration server, and then TSA handles those configurations, and it may expect those to be the same for the mirror, right? And that's what this statement is saying. That is, um, if you locate a mirror node in the second data center, then the data consistency at risk due to potential for a split brain scenario.
Okay, there's see here you mentioned data consistency at risk. Why? Because there's a split brain happen. So a split brain in Terracotta that cause data consistency, not data consistency cause a split brain.
Yes, absolutely.
Okay, now my concern here or my questions about split brain. How we can avoid split brain? Is there any tuning that we should take care about it, or any uh, prerequisite that we need to check to avoid a split brain?
Okay, so this is a part of a different discussion altogether, but whatever like knowledge that I have is we can obviously have third party tools that can synchronize all the artifacts across the sites, and Terracotta will just perform the failover, but the failover tuning feature will be improved because there will be a guaranteed data consistency, right? So I don't have the exact solution as of now, but that is what we can actually implement for a failover tuning feature.
Is there any part in these sessions about configuring Terracotta cluster?
I can actually, whatever we discussed about the architecture, that is, the Terracotta server clustering feature by using the, the off-heap memory, that is the big memory. So that is part of this discussion.
No. That part about caching. Now we are talking about Terracotta module itself, Terracotta installation and configuration for the cluster. Same to what you did yesterday about installation for the web method integrations. Is there any part in this session about installing Terracotta and configuring a cluster?
Yes. So let me show you that again.
No. Not integration server cluster. Terracotta itself. About configuring strip 1, for example, strip 2 inside Terracotta.
See, I don't have a specific Terracotta cluster as a different strip, but what I'm trying to show you is the configuration that we have to do as part of the TSA. So if you want to make TSA, or if you want to bring TSA in cluster, you need to have a configuration all set in the tcconfig.xml.
Yes, this is the point. tc-config. In this one, in this configurations, okay, what the parameters there? How we can configure the cluster?
Okay.
For example, I need for example, I need 3 servers, okay, clustered, active, standby, and mirror for the Terracotta.
Right. So if you see here, see, I will be sharing you the particular XML. Now, you mentioned that your requirement is for an active and a passive server within a TSA strip, right? Or are there 3 server nodes in a TSA cluster? Can you confirm?
Yes.
Okay. So basically, we have this tcconfig.xml, and it resides in the Terracotta server bin. Now, because I have installed this Terracotta yesterday on the same instance of the integration server, I'm able to show you this setup itself inbuilt, right? But when you open the TSA, that is the tcconfig.xml, there is one portion that is for the servers, and this will be repeated. So say, for example, if I want to add another server, I have to add that particular host and the name of that particular server. And then I have to make this as false, because this will be enabled and this will be on a standby, right?
Okay, how it will become automatically enabled if the active node goes down? How the standby will become up if we make this enabled as false and physical file?
Okay, so there will be a failover mechanism, and we will basically have this particular local host. It will take the control from the active server. And once this failover happens, this particular server, when it goes down, this will take control of it. Now, what I will do is I will form this XML and I will share it with you so that you will get a perfect idea about how this failover happens, right? So I'll share that offline with you. Is that fine?
Okay, fine. For the XML that containing 3 server, okay, active, standby, and a disaster recovery server or a mirror server.
Okay. So you have a requirement for active, standby, and you have a recovery server node, right?
Yes. Yeah.
And you need to actually perform a failover from active, and this standby will then become active.
Should be
And
see. I need to reboot the active node, and standby should be automatically become active. But for
okay,
the failover, what the meaning of failover? I will initiate a failover that recovery node will become active, and the site one will become a mirror node, vice versa.
mm, okay, okay, all right. So got the requirement, and accordingly, I will share you this particular tcconfig.xml.
Okay, thank you.
So that comes in the middle of this today's discussion, and can we take a break of 10 minutes and come back?
Yes, yes.
Thank you so much.
Thank you.
Hello.
Hello.
Hi. So I'm back from break.
Okay.
Kindly confirm if we can start the session.
Okay, let us start.
Thank you. All right, so we have seen the clustering and caching part of the integration server. And what is left is about a few components like the MWS, and Command Central. I would like to confirm, are you using Command Central in your landscape? And do you need, uh, uh, you know, a presentation on that as well?
Yes. See what the components that we are using. We are using API gateway, microservice runtime, universal messaging, command central, Terracotta, active transfer server, active transfer gateway, in addition to Cloud Stream. All of these in our environment.
Okay. So what I see is as part of this training, right? So we are left with the API gateway and developer portal administration, right?
Hmm.
And as you said, like you are also using Command Central and universal messaging. So let me give an overview of Command Central. So to start with, I'll just show a brief on how a Command Central will be installed. So
What about other components is not covered with this training? About, for example, Cloud Stream, Active Transfer Server, Active Transfer Gateway, Terracotta is not covered in this session?
okay, so Terracotta installation we saw yesterday, and the clustering part from TSA, which includes the off heap memory, that is the big memory. So that also we discussed. Now I'll be just having a confirmation about this setup, and I will confirm you about the clustering of this active, standby, and recovery, right, as part of Terracotta server. So that completes the Terracotta training. And for the other components, like the list that I got is about API gateway and developer portal, right? So if you need other components as well, then I can surely discuss and get the SME on board. I mean, we need to schedule those sessions
Okay,
separately.
we need because it's used in our environments and will be primary components. So sure, we need sessions for these for other components.
Okay, so as part of the agenda for the 3 days training, right? So let's complete these components. So by tomorrow, we will complete API gateway and developer portal administration, right? So let me just show you the command central, and okay, so I'm in Empower now, and I'm going to software downloads. In software download center. And over here, I get an option to download the Bootstrapper. So this Bootstrapper is for Software AG Command Central, and it has a specific installation for Windows 64 environment. And we have different installations for different OS. And the one that I have is I have installed on my machine. So okay, so this is the Bootstrapper that I have. So it is a Windows batch file, and the installation is pretty straightforward. We don't need Windows. We don't need Software AG installer to install the Command Central. It can be done through the command line interface. Right. So after we get the Bootstrapper file from Empower, we just have to run the command. That is the command that I need will be something like this. So this is my Bootstrapper file that I have. And then these are all the parameters that I need to pass to the file. So accept license is a mandatory parameter, so it is required. And this component is to install the CC. Then we need to specify the target directory. And in case if we are doing a side-by-side migration, then we have the M parameter. So we can omit -d and -m at the moment. The H will be the host name. And the most important parameters are the small and the capital C. So these are the actual HTTP and HTTPS ports of Command Central. And then the SPM ports, which are small and capital S. And then the admin password. So this particular admin password will be used to log in into the Command Central UI from the administrator account. So the username will be by default created. The password will be mapped to the administrator user, and this will be used while logging into the Command Central UI. Okay, so once we form this particular command in the command line and execute it, it will install the Command Central. It will install the platform manager, and it will activate the Command Central, and it will start the instance on that particular host, right? So the architecture of a Command Central will look something like this. So there is a platform manager, and there is an instance of Software AG Command Central. So let me just go to the properties. So as you can see, the path to executable, this is the service name, right? And the path to executable is Software AG Command Central. wrapper.exe. So I have installed my Command Central in the installation directory, which is different than the software AG installing directory. So if I go into the Command Central, I will have the JVM and the profiles. So in the profiles, I have the Command Central, and over here in the bin, we get the option to start, shut down, and restart. Most importantly, when a Command Central instance is running, similar to integration server, it will have the log file and a anchor file generated. The moment we bring down the instance, these files will also be deleted. So these are the dynamic files, and they actually make sure that no duplicate instance of the component gets started accidentally. So we get an option to start and stop the component from the bin directory. So that is through the command line interface. In case of Linux, it will be the Linux shell script file. The naming convention will be the same. The second option is through the Windows service. Windows service needs to be started as an administrator privilege. And over here, we can point to that particular instance of Command Central, and we can just stop and it will shut down the instance. Now, if we go into the properties, it will have the path to executable. So this will be the installation directory, and the service name will be displayed accordingly. And the instance name will be for the Command Central server with the version 10.15. So that's about the backend installation. Moreover, we also get to see some of the configurations. So we have the custom wrapper. Mostly these config files are not heavily used because there is no need to tweak any of the configurations on a Command Central environment, unlike how we do on an integration server. But the installation directory will contain similar kind of profile. The same with the platform manager. Platform manager also gets an option to shut down and start with a log file and an anchor file. Okay. Then we have the logs directory. We have the platform logs. We have the default logs. So default logs will basically contain the different states. So say, for example, any user authentication failure or the node status, it will be displayed in the logs. If the Command Central goes down, it will be displayed in the default log. So that's about the logging architecture. Okay, so let's come to the actual UI of Command Central. I have installed the Command Central on 2191, and I'm logging into the instance. So I have the universal messaging, I have the MWS, and I have the integration server. So these three components I have installed on one SPM. So this is the SPM for that. On Software AG 1015. So in the instances tab, there are two sections. First let's see the installations. So in the installations, we have two primary sections. One is the local installation, and another one is for the actual web method suite. So in the local installation, we have the actual command central and the SPM for the command central. And these are the actual products that are being installed. And we have the status displayed for the component, any alerts related to CPU or disk space. So as you can see that there is alert generated, and it's just a info, so it is in green state. But if any disk space utilization, it will generate an alert in orange, and we get to see other information like the host, the port, and the alias and the directory. So this is the installation directory of Command Central. Okay. Then we have the installation for the Software AG 1015. So this is the web method suite that we have installed, and it contains the integration server, MWS. Obviously, this is the SPM of the web method suite. Then we have the TSA. I've just tried to install a TSA component, and then the universal messaging server. So the administration activities basically comprise of installing the actual product. If we want to enhance the installations post previous installation. So for that, we need to create the repositories. Before that, we need to connect to Empower from Command Central. So in the CCE, we go to the Command Central server, and in configuration, I have created one alias with my Empower user. So this is my username, alias, description, and the respective password for Empower that I have. So I'll be making use of this alias for all the activities that I'll be doing, like fetching the fixes or the repositories or templates. So let's create a repository. So I'm just connecting to the Software AG repository, and I'm selecting my Empower, giving repository name as 1015 repo. Over here, I need to select the respective operating system. Okay. So we get to see a product list over here. Now, this can be viewed as an substitute to the Software AG installer. We can manage all the future installations through Command Central. So we have the gateway agent, gateway server, API gateway, the DB, and all the required components will be listed up to universal messaging, including Terracotta and Big Memory. Right. So we actually have this repo, and then this repo we have all the options. Like we just need to select the particular OS, and the Empower will then create those particular products for that operating system. For fixes, if we want to create any fixes, so I have just created a fix alias, and if I select the respective windows, and try to check for integration server, I check for the core fix, there you go. So we have all the versions of the core fix, and obviously you can read the content of the fix. If we know the fix ID, then we can directly select that particular fix and we can install it on the installation directory. So that's the README file. Then back to repositories. We can also create assets. So these are basically the GIT templates. And say, for example, if we want to have an asset directly installed, like the API gateway server or any DB component or any MWS server, we can install the particular component through an asset. Then we can also manage the licensing. So if I add, if I already have a license archive, then I just need to choose that file and I can add it to Command Central. So here you can see that I have imported the license file and it gives me the product name, the respective license file. If I want, I can download the license file. It gives me the expiration date also, and it becomes very easy to view at one go or one glance. I just need to select that license key and I can directly install it. So up to trading networks. And then templates. So I can also import a template in case if I have a template handy. Coming back to installations, as part of the admin configurations, we can perform different configurations. The most important one is it gives a one view monitoring of the components. So we don't need to basically enter into a particular server and check what's happening in that server. If I actually find that there is a component which is not responding, I can manage or I can start that particular component remotely from the command central. The same thing with integration server. So I get to see all these details which are present on the integration server, like the alias definitions or the JNDI. So this is the JNDI we created yesterday. We can edit the JNDI and we can save it remotely from here. We can also view the logs. So all the different logs that are available, they are accessible remotely from the command central. And the triggers. So currently we have not defined any triggers. We can shut down the integration server remotely from the command central. Then we have the monitoring component, trading networks, active transfer, JDBC. So we don't have any adapter connections. So this is for the integration server. We have the MWS. So again, we have two components, that is my web method server and trading networks that we have installed. In case we wish to install BPM, it will be installed and accordingly it will be listed over here on the left hand side. These are the logs, the MWS logs. The universal messaging configuration. So in universal messaging, we have created a few channels. So if we want to view a particular queue, this is a custom queue that I had created yesterday. And in case if there are any connection factories, they will be listed here. It's the memory size. We can also consider editing the memory, the heap memory and the max memory. So we have this port number, the general configurations. And from the backend, as I mentioned, we have this installation directory with the update manager installed specifically for the command center. Any questions? Okay. So we can move to the universal messaging. So this is basically for Windows installation. We can get an option to administer the universal messaging. We have two options. We have the enterprise manager and the enterprise viewer. Generally, we prefer using the enterprise manager because it comes with more roles. So I have the universal messaging up and running. The first thing that a developer does is in the JNDI tab, we need to create assets, mainly three assets, that is the connection factories and the queues and topics are to be created. So these are the custom assets that I have created. So I have the SAG-IS as the connection factory, then the SAG queue and SAG topic. So the difference between a queue and topic is that a queue has a one-to-one mapping from the publisher to the subscriber. For a topic, a single message or a document can be broadcasted to multiple subscribers. Then we have the relim information. So we have one relim and the cluster is on server. But at the moment, we only have one instance of universal messaging. So generally, the configuration for universal messaging is in an active to active clustering. And if there are more than one nodes, then one of them becomes a master and the other two becomes as a slave. So if the master goes down, the slave automatically becomes the new master that manages the other node. So here you see the server instance, that is the instance server, the number of threads that are consumed, and you have the memory usage. I'm sorry, I'm not able to increase the font, but hope you guys are able to read through the screen. Let me know if you have any issues.
No, it's readable.
Okay, thank you. So we have the memory and the event status. So the total number of published events, total number of consumed events, and the interface, the host and the port number along with the protocol. Coming to the comms, we have the port configuration with the protocol as NHP, the status, and the port number. Over here, we see the status of that particular port. So the status, you get to see how many total threads are idle and how many total connections have been established. So if the idle thread goes up, it means that there is some issue to either publish or subscribe. So we have the basic tab, plugins, the JavaScript, and then we move to the security. So in universal messaging, the same type of user management is followed. So we have the ACLs. In that we have the users and the access permission, like manage ACL. We have either full access, configuration, channels, relims, admin API. Monitoring. And this gives the performance of the on-heap memory of universal messaging and the one look view, including the event status, the connection status, memory usage, and the total. Okay. Then in comms interfaces, we can add an interface. Coming to the JNDI, a connection factory will be associated with a connection by the integration server. And the queues and topics will be accordingly available for publish and subscribe. Okay, and in monitoring, we can obviously see the connections, and we can take action on these connections. So in the name column, we get to see the to JMS connection, or if it's JNDI connection, and the universal messaging SPM plugins. Then the thread management. And here we can see the categorized view of how many connections are using which you know, artifact, whether it's a queue or topic. Okay. So for the ACLs, we can add any ACL. So SAG user at the rate. And then we can manage the access for full or configure or channels or realms. The restart procedure is very simple over here. Just need to go to the installation directory, universal messaging. In universal messaging server, server bin, there is nserver.pat, and you have the nstop server. Right. So these will actually start the universal messaging. Okay, and so that's about Any questions, please? These components.
What about clustering in universal messaging?
Yes. So as I said, in universal messaging, first of all, it is active cluster, and these are the realms.
What do you mean?
And
What do you mean active cluster?
okay, in active cluster, if say for example, we configure 3 realm nodes that form one cluster, that is node A, node B, and node C, right? So node A will also get the request, node B will also get the request, and node C will also get the request at the same time. Okay, but one will be master and the other two will be slave. If, for example, something happens to the master and it goes down, then automatically the the other node will become master from slave, but it will still keep receiving the requests and completing or routing the documents to the destination folder.
Okay. What about? I think there is something related to a cluster about fault tolerance or quorum.
Sorry?
I think there is something related to a cluster in universal messaging about
Mhm.
fault tolerance and quorum related to a number of nodes, because we have environments with the 3 nodes. Okay, if one node goes down, all the cluster and all the nodes will become down. If you can
Okay.
explain more about clustering in universal messaging, please. How to create a cluster?
Okay, so here I need to add a particular realm. Okay, and the mount points in the namespace, the mount point has to be the same. So it will basically add a realm, and this particular realm will be part of the same cluster. But to form a cluster, we first have to add the realms. Okay, so if there are 2 or multiple realms, they will be added here. Now, in a cluster, we first need to create a cluster. Say if I give cluster name as SAG cluster, then I already have a server which I have added in the realm. So I'm going to add that as a cluster member, and I click OK. But the requirement for a cluster is at least 2 realms. Okay. So what I will do is I will create another instance. I mean, not now, but the procedure for creating a cluster. That's what I'm talking about. So first I will create a new instance of server, and then I will connect to that realm, the realm name, so that it will appear here. Then I will go to cluster. I'll create a cluster, and there will be another entry in available realms. So we need to add both the realms as part of the cluster member, and click OK, and it will form the cluster for the universal messaging.
About data, it's persistent to a disk or in memory.
Data is persistent on disk. So audit settings, we have certain settings for that as well. But let me just close this one. And if I go in the universal messaging server, server data, so you see that we have a SAG queue and a SAG topic. So these are defined here. In the JNDI. So we have a SAG topic and we have a SAG queue. And you will see the data for that being created in universal messaging server, server data. So this is the data directory. So what happens is once the cluster is formed, the synchronization happens automatically.
But for the recovery, now this is clustering in the same site. When we are talking about disaster recovery, how this can be managed?
See, first of all, when we have 3 members in a cluster environment, if the master goes down, then ideally the slave, the other 2 nodes are the slave. So out of that, one slave will become a master, and until the master node, which is shut down, it comes up, it will remain as the master. Once the actual master is available, it will take on as the role of the master again. But with having said that, the fault tolerance and the uptime of the nodes, it is basically there is no zero downtime as such in a cluster environment.
Okay.
And one more thing, you mentioned that you have 3 nodes in a cluster, right? But
Yes.
you also mentioned that if one node goes down, the whole cluster becomes unavailable.
Yes,
Is that
because
correct?
yes, correct. Because we see in the log files saying about quorum numbers. That meaning it should be odd numbers available nodes.
See, odd number of nodes is a different aspect of a cluster formation. But say, for example, if I have another 2 members like server 1 and server 2 along with this node, if this goes down, then I should still have server 1 and server 2 as part of the cluster.
But in real case, this is not happen. If one node goes down, all the cluster goes down related to a fault tolerance.
Then it is, I would say that the cluster formation is not correct. Ideally, there is no other configuration that we have to do separately, either on the backend or through any command line for the cluster formation to happen. So what we can do is we can actually, like, as you said, there are 3 nodes in a cluster. You can deactivate the cluster and you can, but that's a maintenance activity that you have to do once in a while. You can bring all the members out of the cluster and a new cluster can be formed on the universal messaging. Because what I understand is from your inputs, that is not the ideal way. There has to be a complete fault tolerance with 99 plus% of availability.
Okay.
So ideally speaking, from software AG perspective, if one node, maybe it is a master or it is a slave, if it goes down, the cluster still is active. And the other two nodes, they serve the request. Or publish and subscribe.
What about recovery or disaster recovery side?
So we can have one cluster in one site and then another cluster in another site. And there will be a disaster recovery or a failover that needs to be administered by a third-party agent. And the data center from site 1 to site 2 will happen from cluster 1 to cluster 2. So there will be one cluster in site 1 and there will be another cluster in site 2.
So the third-party agent will be responsible about failover. What about syncing the data? For example, topics, queues, all of this. How this can be synced within a software AG components?
Okay, so from a clustering perspective, the syncing of the queues, topics, and other artifacts. Again, I have to get back to you on that question. Across the sites, again, I have not implemented that. But from software AG perspective, if all the nodes are in cluster, then they are automatically synced in one cluster as a member. But across the site, we need to check that.
Okay, but see, if for the syncing mechanism, is it sync or async mechanism to sync the data between nodes? Because because I think if it's sync and we are syncing with the second site, I think this will impact the performance. What the mechanism for syncing?
No, it will not impact the performance. First of all, there are two types of syncing that we are talking here. One is syncing in between the nodes of one common cluster.
Yes.
Right? So that syncing happens automatically when all the three members are part of the cluster. They are a member of the cluster. So if you see that, if in case I don't have it right now, but if I add other two members here, and if they form the cluster, then these artifacts will also be synced automatically. So say if there are three servers which are installed on three separate nodes, three separate virtual machines, and if we bring them in cluster, then this data directory should be automatically synced.
Okay.
But across the sites and how that is implemented or how that happens, that is a point of discussion, and I need to get back to you on that again.
Okay, thank you.
So when you say site, does that mean it's a data center?
Yes, recovery data center or disaster recovery data center. We have two data center. main data center, and disaster recovery data center, it's a standby data center.
Okay. Okay. So the standby will be up, right?
Yes, will be
It,
up.
it,
and-
it, it will
yes,
not be
up.
active.
No, it will be up in a standby mode, and the data should be synced between these two data centers.
Okay. Okay. Got it. So I will check on that, and I will see what strategy we follow to basically sync up data across sites.
Okay, thank you.
So that's for the universal messaging. From the integration server side, right? So there is one more configuration that we have to do on top of yesterday's configuration. Okay, so yesterday we tested the JNDI alias for the IS2EM, and in the JMS settings, we need to create the JMS connection alias. So here we have to create connection using JNDI lookup, and if we select JNDI lookup, it will automatically pop up the alias for the JNDI provider. So the connection factory should be the one that we have mentioned in the JNDI, that is SAG IS. The connection name alias would be alias. Okay, and we have the connection alias that is saved. Now we can create the triggers in integration server, and these triggers can actually use the connection alias definition. So let me just check the IS2EM connectivity. Okay, so now we have the connection alias enabled. And then we can go ahead and we can create the JMS triggers. So JMS triggers, we can do that in the designer. So say, for example, we had the supplier management package. So here we have the JMS trigger. And we need to provide the JMS connection alias. It is a standard, we need to give standard. And then we can just perform the different entries. So the destination name should be entered. So it can be actually a queue or a topic. And these are the JMS value and subscriber names in case if we have to use them. And for message routing, there will be the rules that we need to create. So we have a new JMS trigger created. And there will be the supplier management trigger that we can see here. So as of now, it is disabled. So we need to configure the service in the designer. But for that, we need to give the message selector as well. Okay. So this is a basic PubSub integration via universal messaging. So we can have a publishing service. So this publishing service can obviously publish to the queue. And the trigger will pick up the documents based upon the filter, and it will invoke the service. So any questions on universal messaging?
Regarding this disk, the message writing to the data in the folder in the disk, there was two options related to the message sent to through GMS, persistent data or non-persistent. So in case of non-persistent, it also written in the disk or kept in memory.
No, non-persistent will always be volatile, and it will not be written to the disk.
Okay, so how we can manage the maybe the pending messaging or maintain this portion for the messaging, or the how to monitor the pending messaging inside the topics queues, or did messages inside the universal messaging.
Okay, so let's talk about the persistent messaging. So in persistent messaging, we have a document which travels from a publisher to a subscriber, and those documents reside on disk, right? So you can obviously have a certain document, and you can make it persistent. So in case if there is a failure, or say, for example, if there is a fatal error that happens, then persistent documents will obviously reside on memory. And the non-persistent documents that are obviously volatile, they cannot be retrieved, right? So does that answer your question, or you had a different scenario?
Okay, that means the only persistent data can be moved between or to be part of the recovery or failover activity, right? To monitor this, the resident messages in the data in the disk only. For other, it will be flushed and they will not able to process inside from the other data center. That's correct, right?
Yes, that's correct. But then now we are also talking about data across different data centers.
Right. But for the persistent one, also it will be synced through the same cluster, all nodes in memory, or it just served directly from the memory in the single node.
Okay, so for persistent data, there is no need for synchronization because you already have that particular documents saved on disk, right? So what happens is, say, for example, if a master goes down, then you will have the volatile documents accessible to the other node. I'm talking about 3 different nodes in a same cluster. Now, this is a scenario for one cluster across one site only. So if one node goes down, the other 2 nodes have access to the persistent data, right? Because we generally deploy servers on you know, separate VMs or separate servers. So they will be having their individual memories. So if a particular document is not persistent, that means it will be having its existence only in the memory of that virtual machine. So are you getting what I'm trying to say? Now, if this particular server of one virtual machine, it goes down, and if the data is not persistent, then it won't be synchronized because the synchronization only happens for the available documents, and the guaranteed documents that persist on disk, they will be synchronized because they are always available for the other cluster members to either access or to use them even during the downtime of that particular node. Now, this is in between members of a clustered environment. Now, again, synchronization across data centers. So when a failover has to happen from one data center to another data center. So I believe the question remains the same for the previous components, right? So for persistent data, obviously the data is available, but then how it will be synchronized, that is a question that needs to be answered.
Okay, thank you.
So, excuse me, for the triggers, it can be only created in the designer, can't be created in the UI.
Okay, so this is a JMS trigger UI, and it doesn't have an option to create the JMS triggers, but we can control the previously created triggers, and the triggers can be created in the designer because we need to give the options for the JMS triggers, like the message routing and the destination, like we have given the queue as a destination type.
What you mean by control here from the UI is only to enable or disable the trigger or something else?
Okay. So here the control for trigger is either you can enable or disable the trigger from the UI. right? You don't get an option to create a trigger or a JMS trigger specifically. You can search for the triggers with the trigger name, okay, or a connection alias. And you can edit the controls. However, you don't get an option to create the triggers in the UI.
Okay.
So
So
there's
about
direct. Sorry,
okay,
Abu.
continue, Abraham, continue.
No. So there's direct link between the designer and the UI here, right? So if I remove the trigger or something, even if it has messages in the queue, will that affect anything? Or should I disable or turn off the server first, then remove from the designer?
Okay, so there are three states. One is enabled, then suspended, and disabled. So when you suspend a trigger, the documents will remain in the memory of that trigger. It's only when you disable the trigger, the documents will be discarded permanently. So you need to suspend the trigger, and when you suspend a trigger, the documents will still be in queue. So once you again enable it, the pending documents will be picked up and the respective destination service will be invoked by the trigger.
Sorry, the trigger, the purpose for the trigger here is only to process the message inside the queue or the topic, right? So disable the trigger should not affect the messages inside the queue or the topic. It will be, yani, if there is no trigger about this topic or the queue, I'm still able to push messages to the queue, right?
See, pushing messages to the queue is through a publisher service, right? A publisher,
right?
So a publisher service, it pushes the message to the queue. So when you disable a trigger, the messages will get piled up in the queue. Okay. Either you disable or you suspend the trigger, all the messages will get saved in the trigger queue. Now, there is one more aspect of a queue that we need to understand is there is this queue. Okay. So you have the memory usage and you have the used space. Now we generally do not define a used space or a capacity for any queue. But to answer your question, any messages that are already in the queue, they will keep piling in the queue. And once you enable the trigger will pick up in a, all the remaining documents and the concerned service, that is the target service, it will be invoked.
You're right. This is what I'm expecting. So disable the trigger, not push all or clear the message resident in the queue, but it only stop serving this messaging, and it will not pick up the message and push this information to whatever the flow or the surface to process, right? So now, if you come back to the number of threads related to the trigger, how we can control or calculate the efficient number of threads should I يعني dedicate it to this trigger to make this يعني to make the processing should be in high performance.
Okay. So there is a property called as message processing. In message processing, you get two options: processing mode. Either you have serial or you have concurrent. So in a serial mode, the documents will be picked up serially. So when one invocation happens, it gets completed. After that, only the second processing will start. So that's for the serial. For concurrent, if you make maximum execution threads as 2 and say there are 4 documents in the queue, then 2 documents will be picked up and there will be 2 invocations of the target service. So that's what they call it as concurrent. So one at a time, there will be 2 invocations. So the remaining 2 will be picked up in the next cycle. Does that answer your question?
Okay, this is a configuration related to the how the listener deal with the queue messaging. Maybe it is need to be FIFO or something like this. So I need to keep the order. So I need to make serial or concurrent, and I can control the max execution thread at the same time, which is the max number. And what about the batch message, max batch size? It should be in getting pick up a patch number in like 10 by 10 or 100 by 100 by 100 message and start processing this.
See, in one batch, if you want 2 documents to be picked up, and if you want execution threads to be 2, then this configuration will actually pick up 2 documents simultaneously from the queue, and this will lead to 2 invocations of this service. Okay, but if I make one as a max batch message, and if I keep the max execution threads as 2, still, because I have only one message that will be picked up in a batch, only one invocation will happen for this service. Similarly, if I make this as 3, although 3 documents will be picked up at one go from the queue if they are available, but because I have kept this count as 2 for max execution threads, so from the 3 documents that are picked, only 2 threads of this service will be invoked, and there will be 1 document pending in the batch, which will be taken care in the next turn when the execution gets completed.
Okay, what about the connection count? This is what is this control for? What is this protocol?
This is basically the connection parameter to the queue, and the connection count will basically ensure that in one connection, or like say for example, in one connection you will have these many changes that you can perform.
What about the thread configuration in the listener from the software, the portal? If you go to the portal to enable or disable. What about the configuration from the portal? Can you come back to the portal?
Over here.
The portal itself, not the management. The portal. It's the listener in the portal.
Okay.
There is a maximum thread and the current threads.
Okay.
Changing in the thread number or thread super. What is the correct thread maximum thread configuration to make the tuning so for this trigger?
Okay, so first of all, as we have changed this property here, right? Max execution threads. So it's the same as max threads here. Now, what you are asking me is what would be the deciding factor to confirm the maximum threads, right? Is that your question?
Yes, right.
Okay. So say, for example, this particular queue is having, say, for example, thousands of documents per minute, which are getting, dumped in this queue. That means that one processing is going to just make this queue filled up very fast, and it's not going to be any good for the performance of the universal messaging. So if you see, based upon the volumetrics of that particular documents that arrive, we need to analyze per minute count or per second count. It depends upon the volume of the incoming documents, either in the queue or the topics. Based on that, we have to analyze and we have to take a decision what would be the maximum threads that can be invoked for this trigger. So this is purely a live data analysis that we have to do. And based upon the volumetrics, this decision can be made accordingly.
Thank you.
But it is a very important thing, performance analysis and optimization of a publish subscribe model. It is completely dependent on the volumetrics of the live data, and it's very important for the health of the triggers, the integration server, and the universal messaging.
So what is the factors affecting the performance related to publishing data to queue or the topic? Is there any tuning factors that can be configured on the published services or the universal messaging cluster configuration? to optimize or tuning the performance and the number of response time related to publishing the messages.
Okay, so one performance tuning would be the horizontal scaling. If you have 3 nodes in a cluster, then say, for example, the load of that particular JNDI artifact, say if the pending messages over here are 100, then it will get divided among the cluster nodes and the load will be balanced so that all of the all of the nodes, they perform at the optimum level without having any documents pending in a particular queue. So that is one performance tuning that we can have. Second performance tuning would be to allocate more disk space for persistent documents on disk, increasing the memory of the universal messaging server on all the nodes, and obviously the service level optimization based upon the message processing. Then we have the transaction type. We can keep it to no transaction. And things like, detect duplicates or time to live history. Okay, so I think we are on time for the closure of this session. And for the performance tuning, there are a few checklists that I have. Apart from the suggestions or the performance tuning options that we discussed, basically on the integration server level as well, we can actually increase the number of integration servers so that the triggers can actually scale up the invocations as well. Okay, so we can close the today's session with the time permits today and meet tomorrow.
Okay, thank you.
Oh, okay, have a good day. Thank you.
You're welcome. Thank you.
Thank you. Bye-bye.
Thank you.